everyone, my name is Jazli and I'm a final year computer engineering student at NTU. I'll be sharing with you all regarding my FYP. Before proposing an idea to my supervisor, Dr. Suraf, I wanted to make sure that it was something that I would be willing to work on beyond the period of FYP. As someone who has always been interested in visual arts, I knew that computer vision was a field that I wanted to work on. I did my research on the various fields of computer vision, and one field that stood out to me the most was post-estimation. I thought of how different industries and different activities could benefit from the usage of post-estimation. There's a myriad of use cases for it, from sports to dance to performing arts and even acting. With that, I shifted my focus towards dancing. The one industry that I was especially keen to focus on in my project was the industry of Korean pop. As someone who listens to K-pop, I roughly know the process behind conceptualizing of dance movements and training. While doing my reading, I found an article on Vulcan Post, which talks about a Singaporean dancer who actually choreographed for a Korean pop group. In the article, he talked about the processes behind conceptualizing a choreography for an idol band in Korea. The method behind teaching a particular choreography overseas to a group in Korea is pretty complex. Choreographer will record his choreography and send it over to a dancer in Korea. This dancer is actually the teacher of the idol group, who will learn the dance that is uploaded and reteach it to the idol members. That was when I thought of a possible motivation for my project. What if I can develop a platform that can actually facilitate the input of videos, measuring the accuracy between poses, and actually feedback to the users on the various points that they can improve on. With this idea, I laid out my objectives for the project, which consists of mainly 3 parts. Firstly, I have to ensure that both videos are of the same length and are synchronized at the start. Second, I have to choose on a model to work on that can actually facilitate in feature extraction, which I can then process following to my third step, using the data from my feature extraction to measure the similarity between the different poses of the different videos. So for the first part of the project, which is synchronizing the videos and ensuring that they are of the same duration. For this, I utilized 2 different libraries, FFmpeg as well as LightRosa. They are both libraries that provide methods that can facilitate in managing of audio files. I use FFmpeg to actually extract the audio from the video. Following that, I will use the load method in LightRosa, which helps to actually convert the audio file into PCM waves for me to visualize it as a graph. I can then perform various operations. In order for me to actually match the peaks of the audio together, I had to use the autocorrelate function. Cross-correlation is a common method when it comes to digital signals processing, which actually acts as a sliding window to match up peaks of different signal waves. Using this, I'll be able to actually find the offset of the 2 different audio files. And from there, I can actually minus off the offset from the audio file onto the video, which will actually help me match up the synchronization. Of course, to do this, I will have to have one video that acts as a reference, and that will actually be the instructor video. The student video should be shorter than the instructor video, and it should act as a sliding window to find particular peak in the instructor video for it to actually match up to. Once I've synchronized the 2 video files, I'll then head on to working on the post-estimation model. So one key aspect of the post-estimation model that I researched on was feature extraction. I have to make sure that using this model, I'll be able to obtain the data that I needed for me to measure the similarity between the poses. After much research, I decided to focus on a single 2D post-estimation model. It's called OpenPost. Using this, I thought of the dataset that I could utilize. One particular dataset that stood out to me was the COCO dataset. The COCO dataset, also known as the Common Objects in Context, maps out the human body into 18 different joints. Using this information, I can actually get the X and Y coordinates of each joint, perform various operations on it to help me get an estimate or some kind of formula for me to compare between the 2 different videos. Once I've done feature extraction and gathered the data that I needed, I have to come up with an algorithm that helps me to flexibly calculate the similarity between the poses. I realized that there's a lot of consideration that I have to take into account for this part of the project. The first method that I actually looked upon was cosine similarity. Cosine similarity is a very common tool in computer vision whereby it compares the similarity in text. What it actually does is it measures the similarity between 2 different vectors of an inner product space. Although this method works to a certain extent, I realized that it was not the most feasible one. This is because in order to use cosine similarity, I have to ensure that both footages have very similar images in the sense that the shape of the human have to be similar and the size of them. This means that if the dancer is closer to the camera as compared to the instructor, it might not come up with the best estimate of similarity. I thought of various ways to make this more flexible such that I don't have to worry too much about the size and shape of the dancers in the video. With this, I come up with a very simple solution, which is to use the gradient of the different joints in the videos. With this method, I don't have to worry about the distance or the size of the human body in the video. All it does is it measures the rise overrun of each pair of joints and compare them against the two videos. It doesn't matter how far apart the pair of joints are. All it matters is the slope of the gradient itself. Once I'm able to formulate the gradient of the pair of joints, I actually repeated this process for every frame and come up with the average difference in gradient. With this method, I'm able to come up with a similarity value for each frame. After finding the gradient of each pose, I came up with a method to find the average of every frame. And from there, I can actually come up with an overall average similarity value of how well or how accurate the poses are from the student video as compared to the instructor video. This proved to be a much more accurate and feasible method as compared to the cosine similarity method. And now, I will show you how this program actually works. As you can see, here is an example of a relatively bad frame. Alternatively, is a relatively good frame, which has a score that is lower. The score is ranged from 0 to 1, the lower being the more similar the poses are. I actually thought about what else that can be done using pose estimation after I actually gathered these 2D poses of the dancers. One of the things that I actually thought about was converting these 2D points onto 3D models, whereby I can actually use it for various applications like visual effects, game design, the metaverse, and many more. This has actually been done before, and if I'm able to implement this onto my program, it will have much more applications and it will be a complete platform to serve as a dance teacher. With that, I wrap up my FYP presentation. Thank you.